Hi, how are you? I hope that all of you are in good health and good day to all of you. Dr. Shiva here. Today, I would like to continue the sessions, and today I'm going to cover with you double integral, and this is one of my favorite topic as well, and I hope that this topic basically is one of the very important topic whereby you should master the concept and the idea, because it's a little bit not straightforward. I hope that all of you can exactly follow the teaching, and again I'll repeat again and again, please take a paper and just copy the whatever that I'm writing, because imagine this is a kind of lecture that I'm giving, and hopefully that you can looking at the problem, then you can just copy the work and you can follow my teaching. And some of you already requested to post request me to post my teaching notes, because I will do that, but not now. I want you all to copy the work first. Okay, I don't want all of you depend on my notes simply. Once I just what I scan the notes and give it to you, then you just simply start reading, which I don't prefer that method at all. I want all of you just take a paper and copy. Okay, when you start copy, then you will realize whatever the nitty-gritty of the whole concept that I'm trying to teach. Okay, therefore you will start seeing the steps very clearly, then it will definitely will help you to understand what am I trying to teach you. Okay, today I will going to cover with you what I call it as double integral first. Then today also I'm going to cover with you polar coordinates, polar integral. Okay, I call it that as a polar integral. And I'm going to cover with you three concepts under the double integral, actually polar integral coming into one of the sub integrations. That the concept we're going to change bit, but it's still double integral. And we're going to learn what we call as a we're going to learn triple integral. Okay, triple integral. Here we already learned 2-3 concepts basically. This is a triple, as I said. Triple we already learned for the rectangular. We're going to learn cylindrical integration for the triple cylindrical model, and the last one we're going to learn spherical. Okay, we're going to learn spherical. This is as I say, this topic is not easy in the first place, but because in a common sense, because we're going to embed these logics, this topic inside the call surface integral, which is the coming weeks I will cover that topic, which is one of the, as I said, will be a very advanced topic. Therefore, in order to understand the basic things called surface integral, you need to master the skill double integral, polar integral, triple integral. Then because this topic I already introduced to you rectangular, but this time I'm going to introduce to you what I call it as a cylindrical and spherical coordinate system. Okay, let us I hope that you can see what I'm okay. Yes, you all can see, but I try to make it a little bit okay. Okay. Okay, now the things is rectangular, cylindrical and spherical. Okay, double integral. Now, what we did learn what we call under the 2D model, two-dimensional model. In order to calculate anything, we learned what we call a small portion. Take it as a small portion. Okay, a simple question to ask you: how my eye basically capture the problems? Not to say capture the visual, whatever that you are seeing. Okay, the simple question is basically we are trying to see in a various dimension. The dimension is very something very interesting to really look into, because when you see something, actually we are seeing in a different concept. Call it a here we are learning that as a coordinate system. Okay, the coordinate system that so far you all learn in a 2D, we are trying to use what we call rectangular base. In this rectangular base coordinate system, we are trying to imagine a small rectangular. Okay, we are trying to take it that as a small rectangular, and let's say this rectangle is too small. I will say it's a infinite decimally is a small, and therefore what we are trying to do dy dx basically, and we are trying to see, for example, any object using this 2D object surface, any surfaces, placing this rectangular inside and filling up that. Okay, we are just filling it with a small rectangular. Okay, rectangles. Okay, then it's a very small, very tiny, very minute. Therefore we just place inside the objects, surface object, and we are trying to observe that object as it is, but it's a accuracy based, approximations. Whatever that we are seeing is a infinitesimally, there is some kind of approximations is there. That's what, as you can see in my Einstein, basically when you start seeing the accurately, there you are actually compromising for the accuracy basically. That's the logic, that basic logic that we are using. There is some compromisation in the accuracy. When you start seeing, there is something that we are compromising in this level. Therefore, it's in small, but still we can see the object. Okay, we can see the object. This is a rectangle base. When we learn polar coordinate, we are using a different method. The method basically that we're going to we did learn is another one, but polar is a slightly different. We are using a circle model. Okay, kind of circle model. The logic that we are using here, the circle basically is a del A. This one is also dA. Remember, this is a dA. Overall, we are looking at the dA, but we are taking a minute, small, very tiny dA. And for the circle part here, we are seeing this as dA as what? R theta. Okay, we are trying to see that as r theta. Sorry, it's not r theta anyway. Dr d theta. Very important, dr d theta. We are using dr d theta to get the circle base. That means, okay, what is the limitation of this? Okay, of course I can place it very nicely and I can see the object very well if this is a rectangle base. But some scenario we can see, how do we see this problem in rectangle? For example, in the rectangle, how do you place rectangle in the circle? When you try to place that in a circle, you have some difficulties. You have some difficulty to see that object clearly, because you are trying, but it's small, tiny, but still you are losing a lot of space here. Okay, when you try to squeeze in this small, tiny, although it's a tiny, remember, it's a very tiny, but still this is a little bit exaggerated drawing. Okay, but I'm trying to show, okay, you are, imagine this is a very tiny, then you won't be able to see exact what do you call circle. Okay, you won't be able to see exact circle. Then you are missing lot of space there. That is the problem when you start notice pi play the role here. Okay, that's why very difficult to find the pi in accurate state. That's why pi become an irrational number. It's not a rational number anymore. Okay, pi will go on and go on and on. You see, it will go like a 3, 1, 4 and etc. It will go on and on. You cannot stop that at all. Okay, no one until today, no one found, even a supercomputer won't be able to find the manage to see the end of this. Even you give it to supercomputer will go chaotic until it won't be able to finish the end, the converging point of this. Impossible. Okay, therefore the rules that we are looking at is we are compromising for the accuracy. That's a logic that I wanted to emphasize here. Okay, when you start placing, especially when you circle, but okay, imagine you place the circle. Okay, you try to see, for example, circle, then you are trying to place the circle here, then at least you are getting different accuracy here. We are compromising again. Okay, but you are trying to place it. Okay, we are compromising for certain amount of numbers. Still the accuracy is a matter here. But which one is better? If you ask me, okay, is it this one better? But depends on the context that we are applying. See, which one applying to which, okay? That is the important phenomena that you must understand. Okay, if you want to use rectangular for the circle, definitely you will lose a lot of space. Then your accuracy, the accuracy, you need to sacrifice a lot of for your accuracy. But if you place a circle inside, for example, rectangular, also similar. Okay, therefore the invention, you see, the mathematicians, okay, started realize all these things. There are many things that we need to revise. Therefore they started looking at other alternative or other way to understand this kind of phenomena in a more efficiently. That's why you can see, some of you may ask, sir, double integral I am learning, why am I need to learn polar? Why am I need to learn in the triple integral, rectangular, cylindrical, spherical? There is a way, okay, for the different scenario, this kind of coordinate system will cater for different solutions for the accuracy. Therefore, you will able to accurately solve the problem. Not only solving the problem, but actually it will give you better accuracy. Some cases you won't be able to solve at all. For example, you cannot, like, very hard for you to convert rectangular to the spherical. Very difficult to do that. Later I will demonstrate to you how difficult it will be when you started doing some spherical problem using rectangular. Very complex. You won't be able to solve it like easily. Therefore, then you will know the benefit of this problem, why we should learn different coordinate system. Not only this, limited to this, again I remind you, it's not rectangular, cylindrical, spherical alone. There are other possible coordinate system also exists. I'm just letting you know. Okay, people, there is a potential for various cases. For the hyperbolic scenario, how do they handle? There could be a many different coordinate system, which I don't want to discuss here into detail, but basic idea for you to see the things. Okay, now what about 3D? Okay, what about 3D, 3 dimension? When we're looking at the 3-dimension object, this one is only surface. We are discussing on the surface. Okay, if this is a 3-dimension, we are seeing our eyes actually placing very simple kind of things. Okay, we are our eyes, for example, or animal eyes. If you observe the animal eyes, they are using a various type of way to see the objects. Okay, that's why the God creation is very amazing. Okay, very amazing when you start looking at all these things. Wow, so creative, so amazing. Okay, now looking at this, for example, I wanted to see this cubical object. What is the best way to see this? What is the best way to see this object, to capture this? But still, you see, we are very good, but still we won't be able to see at the back. Here at the back, you see that the portion here behind this cubic. Okay, now, but looking at this, we can see there is a 3D. We are making a small cube. Again, we are using a tiny cube. Okay, tiny cube here, dy dx dz, when placing inside. Okay, we are placing inside here the tiny cube, and we are arranging that to see this object effectively. Okay, therefore this is the basic V. Okay, the volume of the object can be defined as volume dV. Okay, dV, I just place it this. It's a del, but anyway, it's not a matter now. We just say dx, dy, dz. It's all del. It's actually a del, because it's more than one parameter already is supposed to be. But take it that as a d. Is what I'm trying to say is a d, dz. Okay, when you use a d, the tiny cube, and you are placing inside here. Okay, kind of what you call calculation that we are using for the, this is for the rectangular. Okay, rectangular, for the rectangular calculations. Okay, this then what about the cylindrical? Okay, for the cylinder, we are using what we call as is it a too small, too tiny? I hope that you can follow. I worried all the time is like whether you can see the work clearly. Okay, now if this is the scenario, cylindrical, something very different object, you see, can I place here? Definitely you will face some problem with this. Okay, in order to solve this, what is the best way to see? Okay, here there is a circle, and here you can see there is something like a straight line is playing the role. Therefore, one of the way that we can use is a kind of combination of mixture, circle with the straight line. Okay, straight line. Therefore, now I just write for you the dV here. Okay, or del V you want to call it. Later it's all I place it, this is a dV first lah. Small, as long as the message that I wanted to give you here is a infinitesimally small. Okay, infinitesimally small. Okay, what is the best way? Okay, how do we find out this? Okay, here the circle, here the circle. How do I find out the circle? The circle here, here also later I will emphasize that, but I come back later here in this case also. Okay, similar, it works similar in order to find out the surface. I just wrote it down to you, is r theta. You can see the r theta. Okay, this is how do you calculate? Is it a r theta just now? Pi j squared, right? R theta. Okay, that means it's I made a small, but I just wanted to tell you there are two components that involve here. Okay, doesn't matter. I'll later make I will explain to you what is that. Okay, here we come back here. When you see, I place this. Okay, here theta, d theta, and imagine this is one of very small logics that we are using. Afterward I'll explain to you when I start pushing for the when I explaining the cylindrical aspect of that. Okay, this is d, okay, d theta, small d theta. Okay, therefore the small d theta can be explained as here maybe I okay, I'll take it a small chunk of this. This is dr. Okay, what is this? This is will be defined as r d theta. Sorry, just now I imagine this is circumferences. Actually, sorry, this is circumferences only. It's not the area to cover. But okay, I will explain to you. You need to place a r. You see, you're looking at this. You will get a r. I missed that r there. Okay, r. Okay, I place it here. R is the circumferences. It will give you r to the d theta, and the depth of this will cover dr. Therefore, the dv can be explained as, I will explain again later, r d theta dr. Okay, the times of this, and this one. Okay, v dz. Therefore, it's a dz. Okay, the dv can be explained as a r d theta dr dz. Okay, it's a very interesting, right? Later, okay, don't worry, this is an intro only. I'm just giving an intro to you. Okay, now with that, similarly, we're going to learn spherical. Okay, we're going to learn spherical. How to calculate the spherical. Okay, the spherical is something similar. Okay, now this one is something here. I forgot to write this. Okay, we are climbing up like that. Okay, we are climbing up straight. We are climbing up straight. This one. Okay. I already told you my drawing is not that good. This is a DZ. Okay, therefore you can see we are just make it that grow straight. If it is a grow straight, then you can see this is the R, dz. Similarly, we're going to analyze the spherical aspect of that using a small spherical balls. Okay, small spherical balls. These sphericals is later I will teach you what is that the equation for that. But the important things that I want you to understand is we are placing that, imagine, okay, the spherical ball filling in this. Okay, this is what the actual phenomena. Can you agree with me? No, right? You may say, how can the spherical filling in the box? See, you imagine your atom. Okay, you imagine your atom actually filling in the whole surface, right? Not the surface, the whole object, basically. That is a calculation of the mass, right? Therefore, that is actual calculations of the molecules, atomic size, atoms, filling in the whole thing. This is how the people are calculating basically the molecule combination and etc. Okay, we can use a spherical calculation to do that. Okay, we can use a spherical calculation. Okay, with that, something very interesting. This is the way to calculate the things? No. Okay, there are some other concept also that we can use. We can use, for example, I let you know for a housefly. Okay, you can see the eye of housefly is a multi way to see the things. It has a more than one eyes. Actually, it's using what we call hexagon. It's use hexagon to see the things. You see, hexagon. Okay, hexagon. Something very interesting. Okay, very interesting. Hexagon in this case. Okay, some of you may say, hey, okay, is a fly, housefly. You can see housefly. You take a housefly, and I think those already study the biology. in form 6 or matriculation, most probably you might learn all these things, right? Bird eye, sorry, not a bird, basically for housefly, it's using a what do you call hexagon. Okay, in practical life, do we using this kind of what do you call method, coordinate system to evaluate or to calculate something? Is there any practical what do you call application using this kind of coordinate system to calculate or to use in the practical life? Yes, it's true. Some of you started looking at that. Actually, our handphone, okay, our handphone rooming system. Actually, rooming system basically using this. Okay, it's using hexagon to this thing. If you move one place to the another place, the rooming model is basically is a hexagon. They are using hexagon. Okay, the question is why? Okay, I'm not going to tell all this thing in detail, but you study this, you will be very excited with that. Oh, actually, it's something very different. Why are we using hexagon? Okay, hexagon in a phone, right? As I already told you, this is being used for cell phone. Okay, cell phone. Okay, your this is, we call it this cell is this is actually cell. Okay, they're using the cell and they are calculating for the actual scenario. Something very interesting, right? Okay, therefore you know now what is the reason why we should learn the coordinate system. Okay, coordinate system play the very important role. Okay, can I now do the quick revision with you very quickly? I don't have these things. Okay, what do you call I need to elaborate too detail, therefore I cannot spend more time with this. Okay, we will start looking at double first. Okay, double, and later we move into the triple. Therefore first I concentrate on the double. In simple scenario, when we looking at that 1D, how do we analyze the 1D? Okay, when we use a 1D logics, one dimension, what are we trying to use here is a C1 to the C2, and this is always is a higher. We use higher, and this is we are using lower. I did explain all these things during last semester. Okay, dx. This is basically is a kind of line integral. Okay, we are using a line integral, and we are using this model to evaluate. Okay, to evaluate, for example, okay, if this is the case, we are started looking at analyze. We are trying to analyze one particular line. Basically, this one is a still line, but we can still analyze. We can still analyze the what do you call area. Okay, we can calculate for the area, and slowly this is we use this method. Remember I mentioned this word, it must be higher point and this must be lower point, and we are using a dx as a one of the I, placing I, we are placing the I here. Dx means we are using here x as our I to be placed, and we are looking at, for example, from C1. Okay, which one should be C1, and this one is a C1. Why? What I mean by I, the higher point and the lower point here, always you must remember we are following the coordinate system, that in the coordinate system we need to take the higher point. Okay, highest value. Okay, this one must be lowest value. Okay, what are we referring to? This one is we are referring to the I. Okay, the I is actually is a x-axis base. All this thing is very important. Okay, very important. When I place my I here, this is x-axis base, and you need to look for the x-axis and check, okay, which one is higher value in x-axis, which one is a lower value. Then from there you start calculate the method. Similarly, when I use the model, similar model, but it could be a d1, d2, okay, dy. Similarly, you are placing your eye, you're placing the eye here, okay. It's very important, your eye, how your eye, basically you're placing the eye, okay. This could be like different, you can evaluate differently, but the idea is something that you are trying to see from this view, d1, d2, okay. That's how you are observing for the dy concept. Therefore, dy, you are referring the dy. What is the lowest and highest? Lowest, remember, is a d2. You need to always place the lowest here and highest on the top. Okay, that is the rules. I already several times I already told you. Therefore, when you place this is a y base. Okay, y axis base. Okay. Okay. Now, based on that, we already learned the certain fundamental. Okay, I hope that you manage to copy that. Okay, please slowly follow. Some of you get bored, you may say, sir, I know all these things lah. Okay, yeah, of course, for a while. Okay, I'll go into more detail about this. How this 1D suddenly become 2D. Okay, the 2D logics. Okay, this one is 2. I'm introducing, it suddenly become 2D. 2D means it's like a one surface environment that we are bringing inside. That means we are trying to move into the C1, C2. We are introducing one component, new component called ghosts. What I mean by that? Okay, suddenly I'm introducing one logics called ghosts. I did explain several times to you all. Okay, this one referred to, the I is actually referring to the x-axis, no doubt about this. What is this ghost will do? Okay, the ghost is actually whatever it can be on the top of this. Okay, you are placing the top of some charges or something. It can be like this. Two way to see this problem, this phenomena. Please remember. Okay, how can this become suddenly 2D? Okay, how can it become suddenly is a surface become a 2D, or it can be a slowly I can make it that as a 2D to the 3D also. I can bring it that to the 3D analysis also, but I want you to see this. Okay, if you place something on the surface, okay, you place something the surface, okay, the surface monitoring will be done by this. Okay, this we can see that very nicely the surface can be captured with the dx. Okay, whereby this one very easy to capture. For example, how do we capture this? See, for example, this is 2. For this is 2, and of course it's a 0, no problem here. 2 0, actually 2 0, and dx, I'm placing my eye here. Okay, and this is, we already capture what you call 2 to the 0. And what about the y? Okay, when I place this, immediately I'm taking 0 2, it will cover everything. Because why not playing the role here? Okay, why not changing at all? Okay, therefore my concentration is here. Okay, straight, my eyes straight away I'm placing here, then I can see the whole rectangular. Okay, the rectangle. Okay, now in this case, if something that I place charges, I'm putting up something, I'm adding some charges inside, and now it carries some density. For example, you can make it a density, whatever. I'm throwing some charges inside. Therefore, now this the charges are ghosts. Okay, the charges are ghosts. It can be anything. Again, as I say, it can be a color. It can be anything. Okay, this is how we are adding the second D inside the surface of this. When I place this, see fx. This goes, I call it as fx. Okay, now is a surface, not only we are calculating the surface, but the on the top of that, the surface being added with the gauge information. Okay, the gauge is actually what we call it as a 2D. Okay, I hope that you can understand that. Or sometimes the gauge also can bring this up, okay, you don't want a gauge to be, these things, I can fix it, and it look like a 3D. It's bringing up to the another level, and it can become look like a 3D kind of things. Okay, let's say it's a simple logics that I'm trying to add here. Okay, I pulled up, okay, I pulled up, just okay, imagine. Okay, can you see this one is a F. Okay, on the ground I am taking concentration on this dx here. Later we will see how do we taking, sorry, this is a 1 or 2D only, very sorry, this is not a pulled up here. Okay, this, sorry, very sorry, this is dy dx, right? This is a dy dx, I didn't use that. But if since the logic that I am trying to throw inside here is this one, okay, sorry, later I'll try to introduce to you the 3D, okay, 3D logics, okay. Now I already pulled up for the second. Okay, now as long as you can see that I'm throw something on this surface, then I can identify the calculation of what you call one line. Okay, when from the line integral, then you are taking a small line, you are placing that into surface. Okay, you become a 2D logics. Okay, we are using a 2D logics here. Okay, with that I will introduce to you certain logics to calculate the 2D. Okay, we will go to the 2D model here. Okay, 2D model whereby we use dy dx. Okay, now in the 2D, as I say, this is a combination if it is a fixed rules, but how to make it dynamic, I wanted to show you this dynamic, this one. Okay, in the 2D I'm going to introduce to you this portion. Okay, if there is a case, another case, we are introducing this goes plus the line integral, the line carrying something, or sometime again for this part, again something very interesting phenomena, we can calculate for the line integral also. This is a kind of line. Okay, it's what I mean by that. Some of you say, sir, little bit confusing, sir. Okay, don't worry, I just show. Okay, you take a one line, okay, kind of line. I'm making one ghost on the top of this, or making the ghost running inside here. Excuse me, inside here. Therefore the ghost is a fx, and this one can be dr, as I say. Okay, this is a ghost carrier. Okay, you can see. Okay, finally you can see this is a 1D also. Still the ghost is carrying this one, carried on the one small cable. Okay, now for the 2D, as I say again, we add on another logics as the model that I wanted to emphasize here. It's a kind of, I'm spending more time here, or time running out than quickly I will cover to you the part of this one. I already explained to you G2X. This one is a G2X, this one is a G1X. Okay, this is Y, this is a X. Okay, and okay, let's say I wanted to find out the simple rules is without goes first. Okay, simple rules is I wanted to find out the area of this. Is it possible? Okay, the simple things to calculate here is a C1, and this one will be C2. Okay, I'm placing my eye here. How to calculate? There are way to calculate this. Okay, there are way to calculate because there are two components involved here. Therefore, my eye I'm placing here. Therefore, always remember this must be a fixed Okay, this must be fixed with your eye first. Okay, this must be fixed. Which one? Where am I fixing my eye? I am fixing my eye here in a X. Okay, therefore this must be the X. Okay, my next thing here. Okay, what are the changes taking place inside the Y? Dy. There is a small changes taking place. Okay, small changes taking place here. This every time when you use a 1D, here I cannot move first. Okay, let me put it to you this first. Settle with this. Okay, this one here you must take a higher. You must take the higher value G2x. Okay, this one must be G1 xy. Looking at this one is a y. You look from here. Okay, you're looking from here. Okay, for the my reference is this x. This is x basis. Okay, for the x based, it's very clearly understood. Therefore, I can see this is on the top for the x. Below is this. Therefore, I'm just taking the below. Okay, for the dy. This is from the dy. From the top, I can